In this video, we'll explore triangle inequalities and the geometric mean. Now first, the triangle inequality theorem states that if I take the sum of two of the sides, that it always has to be greater than the third side. And in essence, what we can really look at in a triangle is taking our two shortest sides that we know, and as long as the shortest sides are longer than the third side, then we can always make a triangle. So if I have the values 3.5, 2 8/10, and 4 7/10 centimeters for my three sides, I'd want to say, well, what are my two shortest sides? In this case, it's AB and BC. So that means AC is my longest. If I add 3.5 and 2 8/10, I get 6 3/10 centimeters. Now I'm going to take that and compare it to my longest side and say, yes, that is greater. Since that's greater, I know I can make a triangle, and this is what the triangle would look like. Now at this set, I've got 7 4/10, 1 3/10, 4 2/10. So I know that DE is my longest side, so if I take my other two and sum them together, I get 5.5 centimeters. Well, if I compare 5.5 with 7 4/10, it's less. That means it can't make a triangle, and here's why. If I look at my two sides here, and I've got my 7 4/10, if I actually try to draw it 4 2/10 and 1 3/10, I've got a gap. That means that no matter how close I try to pull these two F points, I can never get them to touch. Now say I had 1 4/10, 6/10 of a centimeter, and then 2 centimeters. GI is definitely my longest side, and then I sum my other two and I get exactly 2 centimeters. Well, here's the problem. When it's exactly the same as the longest side, I don't have a triangle, I have a segment using segment addition postulate. So in essence, what I'm saying is that GI plus IH will equal GH. That's segment addition postulate. So those two sides, when summed, have to be greater. Now another thing we know from the inequalities is that across from the smallest side is the smallest angle, and across from the largest side is the largest angle. And that can be helpful. So if I want to take and order my angles from largest or smallest to largest, I'd look for my smallest side, which is the 2 65/100ths, and opposite it will be my smallest angle, angle K, or LKM. And then my next one, I'm comparing, I got 4 84/100ths versus 6 76/100ths. So this 4 84/100ths, and I look opposite, so that'd be angle M, or LMK. And that means my largest angle would be angle L, which I could also say is angle MLK. Now say I want to order my sides from largest to smallest. So if I'm starting with my largest, I'm going to look for my largest angle. In this case, that's angle N. So I'll look opposite it, and I've got segment OP. Then I'm comparing angle P and angle O. Well, angle P is my next largest, so across from it is ON, which means my smallest side would have to be NP, or PN. Now the geometric mean, say I have three numbers that are part of a geometric sequence, an A, B, and C. What the geometric mean states is that if I create the ratios of A over B and B over C, so using that middle number twice, those two ratios need to be equal. So if I wanted to find the geometric mean of 4 and 9, so I'd have 4, some value in between, and then 9. So I do 4 over x equals x over 9. That gives me x squared equals 36 because I cross multiply, so x would have to be 6. Now we can check that. 4 over 6 is 2/3. 6 over 9 is 2/3. Both ratios equal 2/3, so I know that 4 over 6 equals 6 over 9, so 6 has to be the geometric mean. Now where do we use this? Say that we have a right triangle, and it has to be a right triangle, and we draw in the altitude on that right angle. And altitude is just the perpendicular distance from the angle to the opposite side. Okay, so we've got the right triangle, and then we have this little right angle here with this segment. Okay, so we're making it perpendicular to that opposite side. What we know, and there's many different relationships, but the one that we care about the most states that my segment over my altitude will equal my altitude over my other segment. of how that hypotenuse has been split. Okay, so say I want to find the entire length of my hypotenuse, and what I know is that CB is 6 and AC is 18. Well, I would just have to use my proportion, which is small segment of the hypotenuse over the altitude equals the altitude over the other segment. So I fill in my parts that I know, 6 and 18, and I don't know DC or CD, so I'll plug it into my proportion. So 6 over 18 equals 18 over x. 6x equals 324, so x is 54. So I can plug it in for my question marks, 54. That's DC. And what I wanted to know was dB. So I can plug in 54 here. So I know that dB is going to be the sum of my two small segments, because it's segment addition postulate. So dB would have to be 60.